Yo, welcome. How's it going? It's game dev time. Let's kill the tune. Safe. Happy Wednesday. We're going to make a game. We're going to continue to make a game. And some bugs. How funny. Wait, bear with me. I've changed my monitor setup, so now it's trying to capture the wrong screen, isn't it? Right, hold on a sec. I think I know what I'm doing. No, I don't. There we go. Okay. Sorted. Right. After that very professional start, welcome. Let's go. So what we're going to do today is rebuild our signaling system for the electricity thing. So we're going to create a second little environment over here. And so we need our player to move over there. Our player can just come over here. like that. And then we want a second switch, which we also did bring into the world already, but where is it? There it is. Yeah, it can just be there. That's totally fine. And now what we're going to do is we're going to fuck around with what a switch is and what a door is, and probably break all the stuff over here that works in the process. But we're going to try a different way of processing these signals now, basically. Yeah, that's the vibe. So the problem is that we have these send and receive nodes. We're going to get rid of both of those. Okay, let's save the level now that I've built this new thing. Now let's go into our switch and our door. These are the two things we're really interested in now. Socket wires and all this will come to. Hopefully we don't have to rebuild the wire too much. Like the wire sim. Luckily all of the functionality of how the wire looks and the physics I've made separately. So when we change the wire, the wire sim can just stay the same, and we just change how we control it. But yeah, it's not all, they're not all wrapped up in each other, so that's quite good. So for now, we're just going to work on the switch and the door and getting them connected in a different way to what we have done in the past. We're going to delete the eSend node from the switch. Save. This is scary stuff because it's quite destructive what we're doing, but it needs to be done. And we're going to link these two together in a new way. And if we regret it, we can always roll back, because I did push all this stuff already. I'm pretty sure I did. Maybe I should just double check that I did. I'm certain I did. I did it before. Yeah, the last push I made says we'll likely need to redo most of the electricity and circuit logic. So yeah, that's fine. So yes, we can always roll back if we need to. It spends ages updating itself. I always find. Okay. So. What we need to be thinking in terms of is that the switch and the door should both have a node that is the power node, and that anything that's part of a power circuit should basically behave in the same way. And the only difference will be that the switch is actually creating power, whereas the door is like passing it on. Because everything, let's do a drawing. I drew this last time, but we're going to draw it again. There's kind of like 3 concentric circles, like the Venn diagram of functionality here. There's like things that make power, things that pass the power on, and things that take power. Now, at the very least, everything is in this category. At least, anything that needs to have one of these power nodes on it must, at the very least, react to being powered. And most things will be in this category because they'll react to being powered, but they'll also act as like points in the graph that can pass the power through. So wires, for example, anything that's metal, the water, sockets in the wall. Yeah. And then very, very few things. I think just switches. And maybe we'll make like a battery, something that's just always on that can't be switched on and off. We'll be able to make it. But of course, anything that can make it can also pass it and take it. And anything that can pass it can also take it. Yeah, so it's like that's the kind of hierarchy. But everything should just have one of these nodes. Everything that needs to be a part of the power system should have one. And then, you know, that we have these circuits of them, which could be linked together, however, but most circuits are probably going to be fairly linear, right? There might be like a branch here. If that's like, let's say it's the water is here, and then it comes out. Things might branch a bit at the water, you know? But we're going to have these kinds of things going on. Say this one's sending the power. Whenever any of these things gets updated, it needs to ping the entire graph that it's connected to. Saying you're going to need to update what's going on. So like, for example, if this node gets disconnected for whatever reason, let's say it's a switch in the wall, a lever, and it gets turned off and then it blocks this. What it needs to do is it needs to say to this guy, I'm no longer connected to you. You need to update. And then it also needs to say to this guy, basically, because it's having a change of state, it's going to act out its change of state, which is disconnecting this, and then it's going to say to all the people that it used to be connected to. I think that's the key thing. It has to communicate what it's changed, or it has to change the thing, but then still communicate to the ones that it used to be connected to, even if the change is that it wasn't connected to it. Yeah, so I guess that's a particular type of change where it cuts. It like disconnects. It removes a node to its list of connections. Maybe that's the way to think about it. They need to be able to sort of ping each other. So they need to have references to each other the whole time when they are connected to one another. So yeah, that seems to make sense, and because then whenever anything enters or exits water, it can do that, but the circuitry always goes back looking for whether it's connected to a creator or not. So when this guy has that switch thing, it will say to it will like cut that off, and then it will say to its list of neighbors, hey look, I've cut you off. Hey look, and I guess it needs to decide at that point, because I've now disconnected one side, am I still powered or not? So it needs to kind of send a signal back down the chain, and then whenever a maker of power receives one of these, it needs to like send confirmation that you are powered back down the line. Right? It's kind of like a little update request, and when something that can make power gets an update request, it should send that back, and anything that doesn't receive it should then turn itself off, I suppose. So as an update request is sent, everything should power off. I think that's the kind of system I'm trying to build. I think I've got my head around it. So do we need a list of all the things we expect one of these nodes to be able to do? So it needs to call functions on parents when state changes. So change, it's just, we can make this a lot more concise. Change state of parent. Like power on and power off. It needs to be able to kind of like send an update. It needs to be able to change state of its parent. It needs to like hold on, there's two things here, yeah. Because in some cases the parent of the power node is going to change its state. Like the power node might be on the switch. As the player switches that switch on and off, the making power bit turns on and off. Yusuf, hey, how are you? Big up yourself. Happy Wednesday. So the changing the state of the parent is the take thing. That's functionality that's on the take level. Okay, so let's split our list of things that it can do into these. Because I think in the make category it needs state changed by parent. Yeah, power on and power off, kind of same vibe. And then in terms of passing on, it needs to be able to send an update request, or send an update when so I suppose with the passing as well, the player can change the state of whether something is able to pass. Like this is about it being connected. Change, so it's not really its state, is it? It's about changing it whether it's connected to something or not. So we're not turning it on and off. We are so it needs to be able to keep a list of connected nodes. The ones that can take power, do they need to do that? I guess they do. So I think they all need to keep that list of connected nodes. That's at the very fundamental level. I don't really know if we need a distinction between these two, actually. Think there are going to be things that can only take, that don't pass it, like a door, for example. You're not going to have power going via a door. That's going to connect into the network, but it's only going to be looking at whether any of its connections are connected to power. But that doesn't mean it still needs multiple connections, potentially. So I think there isn't much point in making that distinction. But anyway, I suppose it's a good way of just splitting up the different abilities, regardless of whether all of them can, any object can do it. Anything that has a power node might need to be able to do these things with it. So we'll make it a general purpose thing. And these are the three broad tasks. In order to take power, it needs to change the state of its parent when its state changes, and keep a list of connected nodes, and check if still connected to power source upon request. Send a request to connected nodes to check. Is it hard to? The game dev is hard. Yeah. I've just got a glimpse. My face looks so so bright, like washed out by the white screen I've got up. Let me put Godot back. That's better. Is it hard to keep talking when no one's in the chat? It's usually busier than this, it's true, but I haven't been on for very long, and it's kind of a weird time to be streaming, so I kind of more do it to keep a record of what I'm doing anyway, because all the VODs stay on YouTube, so that's pretty calm. If I want to make devlogs later or whatever, I've just got the footage of all the development, right? So it just makes sense to stream it. Right, I do need to get back to this, though. Let me think. What else? Is there anything else? Add, I guess, to add and remove nodes from the list of connected. Keep a list of connected nodes, but then add/remove nodes from list. And I think when you remove a connection, that needs to be like these connections need to always be like a two-way thing, where both nodes know they're connected to one another. I wonder if the graph should be stored centrally somewhere, rather than expecting the individual objects to keep track of it themselves. But that's probably more complicated. I don't know. I suppose there's two things. There's whether the two nodes are connected to each other or not, and then whether the node is allowing, it's like allowing things through that connection. It really is quite a conundrum. I think if they both, when we add and remove nodes from the list, what we need to do is tell that node, look, I am removing you. And then that node has to say, okay, well, if you're removing me, I'm removing you then. And then they both remove each other. And because that's happened, they then send an update along the chain. Now, the question is do we separate the passing of power from the connection functionality? I think we probably do. So does this make sense? I guess I got to think of some more concrete examples to get my head around it, but and checking if you're still connected is tricky. It seems to me like the easiest thing would be to remove them. So we just say that when if this is a switch here and the player comes and turns it off, then when they turn it off, we just delete that connection. Anything it's connected to gets deleted. And then when it's switched on, whatever process connects things to it, like a cable being plugged in or whatever, it can that can be stored. And that can be dealt with by the object itself, that logic. I think that's easier because then we kind of really, really generalize the actual passing of power around. So it's really crystal clear what's going on with that. Either it's connected to a network of powered things or it isn't. And we'll sort of use the same algorithm that we used with the water in here for sending power through the water. This is the kind of algorithm we want to do, where we have a queue of things to process. We keep a list of things that we've already processed, and then we kind of iterate through all the neighbors. If it's already on the list of things we've already processed, we ignore it. If it's not, then we add it to the process queue, and then we just keep doing that. And that way, whenever an update request comes in, an object can check for itself if it's still connected to something that's making power or not. And those update requests will like ripple through the network. So either that, or we start off by making it so that anything that makes power simply sends that power every frame, and then anything that hasn't been sent one of those confirmations in the last, say, 2 frames turns off. That might be even easier. Well, that could be quite something. Then you're doing it every frame though, which seems like overkill, but it seems like a good place to start potentially, because then we can kind of rein that back into something more reasonable. Well, we'll give this in fact, no, what we'll do is we'll just make it as a new scene. And we'll just call it eNode for electricity. We've got eSend and eReceive, and those will probably get deleted at some point. We'll leave them there for now. Yeah, that's all it is just a script on the node, right? We'll call it eNode, why not? Close those. So looking at this again. There must be like a clever way to do this. Yes, Pete, safe. How you doing? Long time no see, indeed. Yeah, man. We're back. We're back in the saddle. Pinging the whole network every frame seems unnecessary. That said, having it go... If we do this, sending a request to a connected nodes to check if they're still connected, and then every node needs to be able to perform that check, that there's going to be a lot of like overlapping. It's going to be very inefficient because like say it's this node, then what's going to happen is this node's going to check by going through all of its neighbors like this, and then gradually, eventually, it's going to check that one that's got the power and be like, oh, cool, yeah, I do have power. Getting your ass kicked by the lighting rig, otherwise good. Cool. Okay, great. So we're all on it tonight then. Yeah, I'm definitely getting my ass kicked. I've been streaming for like 40 minutes, and so far I've drawn this picture and written this list. But we're honing in, and actually that's not true. I have done a little bit in Godot, like I made a new area for me to play in, which is just a button and a door. So I've done a bit. I've made a new node. Things are happening. But look, this is kind of inefficient because then this guy is going to check all of these nodes, and in doing that, it's going to find this, but it's going to ask everybody else to check too. But I guess it doesn't need to. All it needs to do is tell them all the result, I suppose. So that's the part I'm thinking about now. When one dude has an update request, how can we get it to only happen once? Like, we want to send a signal to this guy to check its neighbors for power. And then as soon as the power's found, it's like, oh, I totally found it. It's like, oh, I totally found it. Oh, thanks, mate. But then everybody else should just be told, hey, look, you guys, you're in my network. Does that make sense? I'm trying to think how you do that. I guess it's got a list of its connected nodes, which would be this one and this one. Oh, and I guess this one as well in this case, if we're looking at this guy here. It's got 3 in his list of connected nodes. So I'd go out to those guys and say, who's in your lists? Gather up everybody's lists, and if it gets a new one like you, oh, okay, cool, who's in your lists? Who's in your lists? Gather all those nodes up. Ask them all in turn, are any of you guys making power? And if they are, then like tell all of the others the update. Like, yes, we are all connected, or no, we aren't. And if every node on the network is able to build the list of the whole of it of its own network, including any neighbors it's just severed with, that's key. No, what it needs to do is it needs the one it's just severed with. It needs to tell it to also do the fucking process. And we're getting somewhere. So make needs to store a var of its making state, right? Is it making or not? And that state is changed by the parent. Is it powering? Let's keep using the word make, because I think it's, is it making power or not? And then the state is changed by the parent. The parent can turn its power on or off, and that would force an update. That would make what you do is you'd turn this off, and then you'd send the request to everyone to check, because then they're like, oh, we might still be connected, but we aren't, nobody's making anymore. Like a relay, if one gets / loses power, it tells the connected ones to recheck themselves and pass it on, so they only update the next in the chain. But that, yeah, I thought about that, but then if it's like a relay, then when it gets back to the power source, that has to get sent back out again. And I can just see it overlapping in weird ways. What I'm thinking is that I think what it should actually do, every node in the network should have the ability to scan the whole graph of the bit it's connected to, and then check the whole thing and update the whole thing. That's my vision. So at any point in the network, you can change something, and when you do, that node you changed takes responsibility for it and just goes, bang, here's a list of all my neighbors and all my neighbors' neighbors and all my neighbors' neighbors' neighbors. Here's just like the whole network I'm connected to. Is anybody in that network? I can't see the cursor in Paint sometimes. Is anybody making? If so, cool, we're all on. If not, cool, we're all off. And if every node has the ability to do that, then whenever it gets changed, you just make that happen. And if what the change is a connection being made or being broken, then both sides of said connection do that independently of each other. They both take responsibility for drawing the whole network from where they are. And sometimes those might overlap, but it shouldn't matter, because they'll both, if they do overlap and they're part of the same network, they will come to the same conclusion. I think that makes sense. And it's like more elegant than doing it every frame. But ultimately, it means that when we get into the water, whenever anything comes in or out of the water, the whole network gets checked. We just make, for certain objects, the act of entering or exiting water will be one of the things that forces the check. And if it enters water and it checks its network and it's powered, then the water's powered. And then if the water flows away, yeah, the water should just be the way it's set up now already. We can reuse what we've already got set up, which is that it just constantly tries to turn itself off. That means, though, that for the sake of being in water, this would have to go every frame, which is so the water would then be triggering it on a framely basis. Which I don't think we want. But I think we have to. It's either that or each piece of water becomes a node in our circuit. So I think when cables are in water, that's when the water would then request that circuit be checked every frame, which gives the water a way of depowering. Yeah. Let's not worry about the water for now. Let's get this basic functionality going. I think I know what we want to do. Let's look at that list again. So I think take and pass are kind of like the same, actually. Check is still connected to power source upon request. Update whole network. Get all nodes in network. Check is still connected to power source. And then update the whole network. That's kind of like a key thing. And then keeping these lists of nodes that are connected and not connected is a thing. And I think we should probably use call deferred whenever we do that. So that it never happens while there's some sort of something else going on in the middle. Why is it so hard to deal with jittering in Godot? What kind of jittering are you getting? Are you making a pixel art game? Might be an argument for a global script. Yeah, I did wonder that. I was thinking about storing the graph somewhere centrally. It could work. I was getting some jittering, and I think one of the things you can do, I should just say, because I'm streaming on YouTube and Twitch right now, so not everyone can see all the chat, I suppose. But the thing about jittering, I remember you could solve with, I feel like it was one of these settings, stretch mode. If it's viewport, then everything is actually that. Yeah, that does look jittery to me. It's not too bad because our resolution is relatively high, but you can see all the edges of the pixels aren't like, it's not the one. You're using viewport. Yeah, so if you go canvas, it's a lot smoother. But I guess you lose the actual pixels, right? You lose the true pixels. But if all your art is proper pixely, I don't know. If your art's, because what I'm using there is like draw calls and stuff like that, so they're coming out at that higher resolution because I'm in canvas. But if all your art, this is just because it's, you know, just some doing rough stuff for development. If all your art was already the right number of pixels, and then you go canvas items there, you definitely get some smooth stuff, but you don't get pixel perfect. Yeah, it's true. I guess that's a trade-off. Oh yeah. Things are going to be getting confused when I run the game now, because all the scripts on this switch won't make sense anymore. It's like, where's my eSend node? And electricity. Oh dear. Where did I save that script? There it is. Can you go in here, please? Make an isometric game. Yeah, no worries. That sounds interesting. Let me know. Let me know how it keeps going. You know. Yeah, that sounds fun. I hear isometric is really, really tricky. But it looks fucking sick. Like, isometric games are the nuts. They're so nostalgic. I love it. Alright, cool. So the variable, let's make it an export variable. Making on by default is false. And then we want some functions for turning this on and off. And these will be changed by the parent. So set making to and here we'll just put state of true or false. I think this makes sense, and then we'll set it to whatever we feed it. So now the parent can turn it on or off. And then this will call update network as well, which is going to be an important one. The first thing update network should do is get the network, which will be in its own function. So let's write that. And I guess in here it will be like okay, so this will also do this. What are you working on? I'll show you a little bit of the game, but I've just broken a lot of the stuff because we're making something new. Oh yeah, I can't actually get out. But we're working on like a puzzle platformer that has some water physics in it, and set on a submarine. And so we're working on the electricity component of it now, because what you can kind of see through this door. So we've got cables and sockets and switches and things, and the idea is you're going to be able to drop cables into the water to power things and stuff. There's lots of it's based on a jam game that we made called Aqua Boy, which you can find on my itch. So you can play the jam game and get an idea of what the what the kind of agenda is. But yeah, I spent a week making all the electricity stuff a couple weeks ago, and I'm redoing it. Well, most of what I made that week I can keep, but the like underlying logic, the way the kind of signals and the power is being sent back and forth, is the bit that needs rebuilding. So this is going to be... We're going to copy this, roughly this kind of algorithm here. So I might just actually copy that function for now, just so I've got it to look at into this script in here. But the other thing is that what I'm just thinking is, does anything apart from the water split the signal? We're not planning on that. So does that mean that everything will only ever have two neighbors? Maximum. You won't get like a component that's connected to more than two things. My old system couldn't, because it just had send and receive, and that wasn't the problem. The problem was that there was a distinction between sending and receiving, but it wasn't a problem that it was a max 2. So it seems like we need a few more. So we call it connection A. Which would be a node 2D. And connection B. And that way then, as developers, we can create scenarios in the game world that are already connected to each other, because we can just drag these things back and forth into each other. But yeah, I think that's fine. And so what we want to do is, the network's going to be like a blank array. I guess it's like the list of processed cells here, isn't it? Because once we process something, we know it's in the we know we've done it. So, because what you basically want to do is you want to say, who are my neighbors? I worry that having two variables here isn't the one. But if this is an array, okay, what about this? Let's just do an experiment here. If that's an array, oh yeah, it's just freaking out because of that script there, that's fine. What does this look like as an export variable? It's just not there. What about when it was node 2D, was it there? Why not? Am I going mad here? What am I doing wrong? Do I just need to delete that so it's not freaking out about everything else? Yes. Okay, so now that there aren't errors in the script, it's more happy to allow me, yeah? So what if this is an array? What does that look like as an export variable? I'm curious to know. Wow. Crikey. Still can't drag things in though. I can load stuff in. No, but I want the specific one from the scene. I want to be able to link to specific dudes in my scene. So node path assign. Okay. Okay, so I think that works. I wonder if there's a shorthand in here for just saying that what we want is for those to all be node paths. Anyway, that's cool then. That's fine. That works. Okay, so we'll have just connections as an array, and that way we can have, it's more future-proof. We can have as many connections as we want in the long run. Let's grab this again. Need to go get another glass of water. Throat's going. So what we're basically saying is we want to get an array of not just our connections, but of our connections and our connections until we've checked them all and there's none left that we haven't found. So there's the network. I guess the network starts as a copy of connections, yeah? And then we say for node in connections. Oh yeah, we need the while first. Yeah. So while. So we need the process queue as well, don't we? So actually, network should start empty, and then we have the process queue, which also starts empty. And then we can append our connections. Oh no, that doesn't work. So what we'll do is we'll just say the process queue is that array. I think that's fine, we can do that. And while the process queue isn't 0, then we're looking at that node. And what we want to do is see if we've processed it already or not. Yeah, I guess because we always want to look at what do we remove it. Yeah, at the end we remove it at 0. So yeah, that makes sense. We basically want to copy this. I'm pretty sure we want to copy it. So, but we're just applying it to a different thing. So var it's annoying because I want to call this node as well. So there's the node that we want to look at. Connection in node.connection. So we're looking at all of the neighbors of the dude that we're about to process. And now it's this. If not network has connection, then it means we haven't looked at it before. Okay, this is where I'm getting a bit confused because the water thing isn't exactly the same as what we're doing. I think this is where I have to think for myself again. If it's not in the network yet, then add it. Network append connection, yeah. And then this is where we do what we want to do with it and add it to the process queue. But hold on, I'm getting confused. At what point do we add that cell itself? We're doing that up here in our version. Because you kind of have to get this loop started, right? So do we start by saying we know for sure that the network has our connections in it? Yeah, they're definitely part of it because we're still connected to them. And then we also need to process them. Then we're going to start by looking at the first one in the list, and we're going to add it if it's not there. And then we're gonna remove that. I think that'll do it. Because what will happen is it will check for both of the connections. Oh no, we need to add. Oh yeah, hold on. The last thing we need to do is this, append that neighbor that we've just looked at. So because it's not in our network, we add it to the network, but we also append it to the process queue. Only if it's not already on our network. And if it's been added to the process queue, yeah. Because if it's not in our network yet, then we've never processed it. I think that'll do it. I think that will get the network. Okay, so I'm going to delete this now so that this script stops totally freaking out. Now, to update the network, it has to get the network, then it has to say for node in network if node dot is making, yeah, is that what I called it? Is making, or no, making on equals true. I think this needs to be a separate function as well. We'll call it check network. And you feed it the network, yeah, feed it the array of all of the dudes. And then here we'll just, we'll have some kind of if check network like that, and then we'll loop through them all and tell them that they're powered. And then this goes for each node if else pass. I mean, I don't think you need to put else pass, you can just put nothing. And then return false, right? So like, it's just going to go through every node in the network, and if it meets any of them that's making power, then return true. So then if check network, now we know that the network is powered. It's like, good news. So then we do another loop. I think I want to call it is making. Is making. Is making is such a weird thing. Powering. Should we call it powering? So now wherever I've put is making, it should, or making on. There. Set powering. And then I don't know if this one needs to be an export actually. This one just by default be false, I suppose. Powered. Same for node in network. Node.powered. It's true. Doesn't need to store this variable like that. Probably can't hurt to. But actually we shouldn't do it like this. We should do set powered. Else, if check network does not return true, then you need to update everybody and tell them that they're not on anymore, and that's when we'll have our set powered and like state, but we don't need to update the network whenever we do that necessarily, do we? Arguably, we shouldn't put it there either. That should just be something that always happens. We just call it separately whenever we need to, rather than it being bundled in with the state changing. That said, I think actually it simply does always have to happen in that one, but it doesn't always have to happen here, because this is only going to be called when somebody's just updated the network. So because this one gets called when that happens, yeah, we don't need to do it. Yeah, it's fine. Why doesn't it like this? Oh, for node in network. What am I doing? Else. For node in network. False. I think that's the best way to write it, because we do this once and then we pick which loop to do, rather than starting a loop and checking this, running this function every time we loop around it. Okay. I think we're getting quite close to all the functionality here, and then we'll just have to go through and change all of the ways that our different objects interact with these nodes and put these nodes onto them all. Let me look at this crazy list I wrote again. We haven't given it a way to change the state of its parent yet. I don't think we're guaranteed, are we, that the parent is ready when it is. A parent tries to get all of its own... In fact, I think by definition it wouldn't be. Because a parent is only ready when all of its children are ready. So unless this is the last child to become ready, it might stand a chance. Otherwise, I don't think this works. But I guess we don't need to... We can just say get parent... I mean, if we know that these e-nodes are always going to be parented to the one that's control... That, you know, that's their relationship with the object. Is they're a child of the thing that they're attached to. Then... And if a battery turns off, then it's going to change its powering state, and then it's going to update the network, and the network is going to get the whole new network, which is going to calculate it from scratch again. Then it's going to check the network, and it's going to say if any node has powering true. But if it was the only one with powering true on, then it's going to be like, nah man, none of us are powering. So then it's going to be like, oh, you know, so you know what we missed? It needs to do itself. Because when it checks its network, it's not going to check itself, because it's not even put itself into the list of connections. I think the network needs to include itself. So we'll take the connections and then we'll self. It doesn't need to add itself to the process queue because it already has its connections in the process queue, and all it's trying to do is find everything on the network. So it can add itself to the network immediately, because he's like, well, I'm sure I'm part of my own network because I am the only thing I'm sure of that's in my network. I might be connected to nothing, but what I can be sure of is that my network contains me. And I suppose, in a way, you could... Actually, the network could start empty and the process queue could just be self. And then you'd add yourself. But I think this logic works basically the same. Hugo, yes. How you doing? Don't I need one loop? Oh yeah, okay, cool. It's with what I was talking about a minute ago. So like this. Result is check the network, and then for the node in the network, do it. Cool. Nice, I like it. This is so much more sleek than what I had before, though. That it's crazy that we're near. I feel like we're nearing the end of the logic already, This just goes to show what spending like a week and a half thinking about something does. This just makes, I think, loads more sense. Store of R if it's making or not, and its state is changed by the parent. The parent can change it by calling set powering. But changing the state of the parent needs to happen when we set powered. So what we do is we'll go get parent dot update powered, or well, I guess we could call it set powered as well, could we? Maybe that's the easiest thing, and we just call the same thing on its parent as well. So anything that's going to have one of these nodes needs a set powered function, and it might itself need a set powering function where it passes it down like this if it's a maker of power, which most things aren't. Keep a list of connected nodes. We've got that in that array. Add and remove nodes from the list. Yes. Yeah, so, okay. So this is, we don't have any logic about changing what you are connected to. So do we want, like, I don't think we need these. I think we want add connection node, and we want remove connection node. Okay, when we add one, connections dot append node, and then I'm just gonna have to remind myself what the correct, it's probably just remove. I can't spell the word connections though. Maybe do you have to find it first and then remove it? Returns the index of the first occurrence of what is in this array. Erin, how's it going? Big up yourself. You alright? I am good and healthy. I think I had a bit of a thing going on at the start of the week. I took a bit of time off work, so I was like actually a bit unwell at the start of the week, but I'm good now. Thank you. So I think this is what we want, because find will give us the index and then we can remove at. So remove at connections.find node, because this will return the index, and the index is what we want to remove. But this is not, it's not that simple. So what we want it to do is we want it to also tell the node self. Yeah. And then both of those nodes need to run update network. So you update the network of the node and you update your own network. But you need to... Yeah, I think that's fine. Because we want to remove the connection on both sides. The only problem is that when we do this on that other node, it's going to do this. It's going to try and do all this shit. So this is a puzzler. Because you only want it all to trigger once. So maybe we don't call this function, we just manually do it from here. So that there's always one dude in control of breaking the link and it just like does it to them both. So what we'd do is we'd say connections remove it, find the node, but then we'd also say this to the node. We say node.connections remove at node.connections find self. And so to that end, then from the parents' points of view, like the objects involved, the wires or whatever, when we're coding in that behavior, we only need one of them to do it. And both sides will update their whole network. That seems like that's a tick. For removing connections, for adding them, we also want to update the network, but it's simpler because once we've added a connection, we now know that we're connected to it, so we can just take control of updating our network, and we know that it's part of the network that we're about to update, so it's done. But also we need to do the two-way relationship, so we need to tell that node that we are a connection of its. If I've done all this right without being able to test any of it along the way, I'll be absolutely, my mind will be blown. I think God, is that it? So now that we've built this thing, let's add it to the switch, and let's add it to the door, and then save. And then let's come into our test level, and we'll make the connection between switch 2 and door 2, which need to have editable children, I expect. Yeah, they do. And then editable children there. Right, let's see if we can do this. So this is the part where the workflow might need to be improved. But if we add an element, now the size becomes 1. For the door, we want it to be a node path, and we want it to be that specific node. And then this specific node also wants the same in reverse. That guy. So now we don't have our tool drawing the connection anymore, but they are now connected. And we could definitely smooth out the workflow for us when we're actually making levels, but for now I just want to see if this works as early as possible. So now they're connected. We just need to come into the switch and the door scripts and just change how these work. So ready, focus off, that's fine, whatever. Get switched. So if it's powered, firstly, it just needs a reference to E node instead of E send node. And then no, powering. The switch is powering things. And it has this variable. Does it need to do that when it's ready as well? Okay. Now the door has turn on and turn off, update, and that's all about okay. So the powered variable is kind of fine. When it's powered, the door is open. Okay. I think that's fine. It's just about it sending these signals as turn on and turn off. What the E node is going to do is actually call something called set powered. So we add our set powered in, fund, and it brings in the state. So powered equals state. And the collider, whether the collider is disabled or not, is also the state. and the sprite is not the state. And then it gets updated. Okay, guys, if this works, yeah, this is one of the greatest achievements of my life to date. I've not tested any of the code I've written because I've had to like build all of this stuff up from scratch again around whatever. So I'm not expecting it to work, but if it does, oh my god, and I'm slightly expecting it to work. No, okay, right, here we go. Invalid access to property or key on actions. I just spell on action. I just can't spell the word connections. It's just a typo. A mere typo. Another typo somewhere. Invalid access to property or key connections on base of type node path. Is node path not what I want? Is there a difference between node path and like an actual node? Node path built in variant type represents a path to a node property or hierarchy of nodes. Right, so it's not the node. So what we need to do is fetches the node. Okay, cool. So this shouldn't be too hard to fix then. So the connections are actually just being stored as node paths. And that was because when I set them up in here, so this is all just in the editor actually that we can fuck around with this. We have our arrays here and they're set up as node paths. I mean, so I'm on the switch right now. Just to be clear, if I change this to an object, I can't drag in this, can I? No. Okay, so I think node path is probably the way to go. Is it though? Maybe I can experiment with that shortly. Maybe for now I should just... because we'll be adding in nodes here. Quite tired, but I want to get the switch opening the door tonight. Like that was my mission, was to just like get the door to open. We're gonna do that. We're definitely doing that before I finish tonight. And I don't think I'm that far from it. This node path thing has stumped me, but it's nothing wrong with my code if I can just get this to be an actual node. So look, here's... Okay, here's the thing. And this brings us back to having a hard limit on how many connections we have. But for now, I think it should be okay. So that's actually a node now. not an array. And then if I do that and I save here, that's all changed. So now connection A for you can be that. Connection A for you can be that. Save. So now they both have the connection in their array. And maybe we don't want null there because that will cause errors too. So maybe instead we want to actually, now we do want to use the ready function to do this. So we'll just make it an empty array at that point. And then when we're ready, if connection A isn't null, then throw it on the pile. This is really hacky, like I don't think we're going to keep it like this, but I just want to test quickly. So we're just building away. And so now what we have is that our connections array is actually an array of the nodes, not the node paths. And I think that means it will work now. Oh my God, moment of truth. Okay, it doesn't work. The door doesn't open. Bollocks. So we need to start adding some comments to things. So we'll start at the very beginning. Print powered there. Okay, let's go. True, false, true, false, true, false, true, false. Okay. So that must mean that the E node set powering to true is happening. So then oh, I see the problem. Set powered. That's what we're doing. The switch is turning. No, wait, hold on. No, it should be powering. Because then so now let's print it there instead and take it out of here. And this should be powering because it's a switch. It's powering things. That's right, isn't it? And that's probably what my problem was, because that variable is called powering, but this is probably checking. When it checks the network, it's looking if things are powering. But our switch only had powered, but now it has powering. Come on then. No, it still doesn't work. Do we also get something like double firing then? It fires false right at the beginning. And then true, false, true, false. So that's right. Okay, so it's making it to here. And then it's updating the network. Yeah, so it's not making it to the door. This is not being called. Okay. Don't know why. You need to set powering powered. What is that on the switch? Oh, I can just put that in there like that. I don't need to do the if, the whole thing, yeah? I think that's what you meant. That makes sense. But what's going on then? So when we update the network, get the whole network, let's print it. It's getting nothing. Interesting. Okay. So get network isn't working. It's funny that the network is nothing because, I mean, it should at the very least have itself on it. What if I try and print it down here before we return it? So this is the bit that isn't working. Not a bug, just a suggestion. Yeah, just improving the standards, bruv. Nice. Well, I can see where this is going. Oh, it gets it like one time and then it's just gone, buddy. Why? Why would it not be able to? Why would it get it once? Need a deep copy of the array. What does that mean? It's something to do with it being duplicated here or something, isn't it? I'm just going to run and grab a glass of water. I'll be right back. Okay, are you removing entries from the same array as network? I'm just adding stuff to it. But we seem to be somehow removing the connections, don't we? But I've confused myself with this stuff before, because when I do this, when I say this equals this, I'm thinking that this is now a copy of that array. Network and process queue are the same. Yeah. So what I want is for this to be a copy of that array. But it's not, is it? This is a reference to that original array. So then whenever I'm fucking around with it, these are all equaling the same thing. Because when I say network append self, what I'm doing is I'm appending myself to actually the original list of connections. So what I want is I want both network and process queue here to be copies of this array of connections, but not a link to that original thing. I've done this before. I've confused myself with these. My assumption for some reason when I with arrays, when I do something like this, is that I'm copying it, but I'm not, am I? So what I want to do is make a new array that is a copy of that. Is there just a way of doing that, like copy array or something? Duplicate. Returns a new copy of the array. By default, a shallow copy is returned. All nested array and dictionary elements are shared with the original array. So duplicate recursive. I don't think I want it to be deep. I think I just want it to be a duplicate, because I still want... Yeah. I think this is my problem. So... Oh, it doesn't like it now. Non-existent function set powered in base node switch. The switch isn't able to accept that. So for now, the easiest thing to do is to just say, look, because you have an E node, you need a set powered function, and for the switch it can just be pass for now. It doesn't need to do anything. It doesn't have a behavior attached to that. Oh. Why doesn't the door have a collider anymore? Maybe because it's like not ready yet. I think I can remove this for now, because that's only if I want something to start turned on, and I can cross that bridge when I come to it. Oh, fuck, yes. 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 We did it. So the very most basic version of it works. And there is a problem there about wanting a switch that defaults to being on. Like if I come in here, that's what the last thing I removed that made it work. If I tick that so that the switch is now powering by default, and we come in and we press play, the door's not open by default. And then when I press it once, now it's shut, now it's open, shut. Yeah, so there's that thing there, but just sending the power when the switch is ready isn't the right thing to do, because the door might not be ready yet. So we've worked our way around those things before. And I think the test level already has a function for this in its script, which is just waking things up that need the whole level to be ready before they happen. So doors and sockets both have these update and start functions, and I guess the switch needs it too. Is in group switch start, and then that code that I deleted from the switch, which was just this, can now be in start. Instead, that's our like process for things that have that problem with them. So now if it's set to powering by default, when we play it should be open. It's not. Okay, that didn't solve it. Oh, because the switch isn't, of course. The switches aren't in a group called switches yet. So add one called switch. And switches now are, nope, that's wrong. No, you're not part of it. You're part of it. Save. The door starts open. Okay, cool. We got it. Powering isn't in scope. Yeah, I think I can standardize this a bit. Like, never mind. Okay. I think there's definitely some more work to be done, even just on how these scripts are like formatted. I want to really get this right. But this is a massive step in the right direction, and so I thought I was going out tomorrow evening, and I'm not. So maybe we'll be back tomorrow evening, and we can just keep working through the objects. So now we'll come into the socket, and we'll remove the send and receive nodes. We'll add in our new node, and we'll update the logic. We'll do the same for the wire. We'll do the same for the... Is that it? Oh no, we need to do the pressure plates. There's quite a few things we've built in the electricity. We've got the pressure plate. Hold on, if I open the pressure plate scene here. Oh, held buttons as well. Door. Held button, plate, socket. Have we got the socket open? We do. Switch, we've done that one, that's open. Wire, that's all open. And that's it. Okay. Okay. So the wooden box is there. Remember why. We can get rid of that for now. We'll close that one, that script as well. There's a load of player state scripts open as well, which we'll close because I hope, and I'm probably wrong, but I don't think we need these ones open because they were open from when we were setting up the wire. But now all of those scripts just call these central functions, which is where we're going to have to maybe update things, but hopefully not, because the way the player interacts with these things should really remain the same. I would have thought we might not need that one. Close all of that. I'll keep all the wire stuff open, the water stuff open, yep, the level, and then all of the player and all of our electrical items. And that seems good to me. So, a successful couple of hours. Yeah. It's very satisfying to start with a drawing like this. But we've done it, I think. And what would be good would be to have a bit of a standard so that all of these things have powered and powering, and we just make sure we get our head around the difference. But what is happening now for this to turn on and off, I believe, is that it's printing the node every time because its whole network is just its mate. All right, where are we printing that? Here. Yeah, we're just saying who's your connections, and every time it's just got one, the doors node. Yeah. So yeah, cool. I'm gonna call it there for tonight. But thanks for tuning in, one and all. Thanks for watching. As always. And yeah, we'll be back tomorrow for more. So yeah, actually, you know what, yes. I need to go and update my roadmap because we're a little behind schedule now with this rebuild of this happening now, but never mind. This is going to be so much better, this system. And this kind of isn't ideal connection A, connection B, but I think it's fine for now. And actually, from a development point of view, it is a slightly more elegant situation because we can just drag and drop the connections straight in. We don't have to do all that messing around with the array thing in there. If we come to a scenario where we need things that connect to more than two things, we'll cross that bridge when we come to it. But I don't think we will, probably. So yeah, thanks for watching. Big up yourselves. Happy Wednesday. Be excellent to each other. And I'll see you next time. Alright, boom. Peace.